Hi, in this video, I'm going to cover up the basic concepts of quadratic sequence. So we'll just first understand the link when a particular sequence is a quadratic sequence, and then you're going to take some problems, and then towards the end, we're going to take an investigation. So let's begin with understanding a quadratic sequence. So well, I'm using one of the slides that was prepared by a group of my students. Now, first question is that what is a quadratic sequence? How do you identify a quadratic sequence? So now, as per the definition of quadratic sequence, where you see that if the second difference is constant between two consecutive numbers, it is called as a quadratic sequence. So let's take an example. Let's take a particular example for this situation. Now, let's just have a look at this particular example where my first term of the sequence is 6, 11, 18, 27, 38, and 51. Now, if I look at the first difference, which is 11 minus 6, which is 5, 18 minus 11, which is 7, 27 minus 18, that's 9, and so on. Now, after this, if I look at the second difference, that is, so this is my first difference. This is the second difference. Now, when I look at the second difference here, my 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is 2, and so on. So since this, my second difference is constant, we call it as a quadratic sequence. So now our question is that if I keep doing this way until infinity, how do I find out a particular term of the sequence? So let us just first find out a way to find out the nth term of this sequence. So this is something that is interesting for this quadratic sequence. All right, so since you know that a quadratic is written as the an square plus bn plus c, now what I'm going to do is I'm just going to first write down, let's say I'm just going to figure out how do we find out this a value. All right, so let's just understand the procedure for this part. Now, when I look at the difference here, you create the difference table. The example is 5, 8, 13, 20, 29, and so on. So if you create the first difference, it is 3, 5, 7, 9. If you create the second difference, it can be clearly seen that it is 2, 2, and 2. Now, this term that you get a is actually by simply dividing the second difference by 2. So let's say I got the second difference is 2 here. You divide by 2, that's 1. So the coefficient of n square is 1. So that's how you get 1n square. Now we're going to talk obviously how do you find out b and c, but it is really interesting if you can remember that way. So now also here, if you look at the second example, it is 4. Now if I divide this 4 by 2, my answer is 2. So the coefficient of n square is actually 2. And similarly here, the second difference you notice is with the one which is 4. So this part is something that is different, a little different. Here is that particular concept that explains how do you find out coefficient of n square. Now let's see how do we get the value of bn and c. So that is something which is really interesting. So taking this particular example, negative 3, 8, 23, 42, and 65. Here, when I take negative 3, 8, 23, 42, and 65, the difference that you get is 11, 15, and 19, and 23. And when you look at the second difference that we get is 4, 4, and 4. So when you look at the coefficient of n squared here, it is 4 divided by 2. So we get already the 2n squared term. And now how do I get the rest of the term, the rest of the bx plus c term? So bn plus c term. So for this part, what we do is we are just gonna write down this sequence, which is 2n squared right below it. Okay, so if I put, let's say for 2n squared sequence, let's say here, if I put n as 1, I get, let's say 2. If I put n as 2 here, so I get, let's say 8. Then if I put n as 3, I get 4. 4 2s are Yeah, so 9 twos are 18. So this is 18. If I put n as 4, what I get is 16 times 2, that is 32. So and so on, you do that. Now, what I'm doing is actually I'm just using my original sequence, which is this one, and I'm going to just subtract these two. Now, when I subtract these two, now what we get is I get 5, negative 5, then I get 0, then I get 5, and 10, and 15, and so on. Now, what you do is, if you look at this, this is arithmetic sequence with a difference of 5. So this is a difference with 5. So what you do is you find out the nth term formula for this. Now, when I look at the nth term formula for arithmetic sequence, it is a plus n minus 1 times difference. So my a is negative 5, so negative 5 plus n, you don't touch it, you don't put any value of n, and difference you get is 5. So if you open up the bracket, you get negative 5 plus 5n minus 5, which is 5n minus 10. So eventually what you get is the 2n squared term in the beginning n plus 5n minus 10. So this is the nth term formula for this, which can be verified easily, simply by plugging n values 1, ns2, ns3, and so on. And you notice that this is giving exact same terms of the sequence. So this formula works. Now let's take another example. So in this example, what we have is like 4, 8, 14, 22, and so on. You notice that the difference here is 4, difference here is 6, and difference here is 8, and so on. I'll notice that the second difference that you get is 2 and 2. So what we do is the coefficient of n square is simply 2 over 2, that is 1. So it is going to be 1n square. Now I just write down 1n square right below it and put the values here. So if I put n as 1 here, I get 1. If I put n as 2, I get 4. If I put n as 3, I get 9, and so on. Now you're going to do one thing is you're going to just subtract this this values that you got here from the original sequence, which is 3, 5. Now it is going to be 14 minus 9. Sorry, this is 4. This is 4. This is 5. Then 6, and so on. So this particular sequence that you notice here, the 3, 4, 5, 6, this is forming an arithmetic sequence, which is the difference 1. So you find out the nth term formula for this, which is 3 plus n minus 1 times difference, which is 1. So it is 3 plus n minus 1, which is n plus 2. And you add this to the original n squared term. So that is n squared plus n plus 2. This is how you get the nth term formula for this. And you can verify using plugging the n values in this particular sequence. Well, so I hope the basic quadratic sequence is clear with the technique that we learned. Now we're going to just do a generalization of the key concepts of the quadratic. So let's say for an arithmetic, for the quadratic sequence, my nth term is given by an squared plus bn plus c, because this is a general quadratic format. Now what I'm going to do is I'm going to basically create a sequence. Let's say when I take, these are the n values, basically the term values, term positions, and this is the nth value, nth term. So if I take a 1, 2, 3, 4, and 5, my first term will be a plus b plus c. If I plug n as 1 here, I get a times 1 plus b times 1 plus c. If I take n as 2 here, so it's going to be 4a plus 2b plus c. If I take n as 3 here, so it is 9a plus 3b plus c. If I take n as 4 here, so it is 16a plus 4b plus c. And if I take 5 here, so it is 25a plus 5b and plus c, and so on. Now what I'm going to do is I'm just going to create my first difference table, that is first difference. And then after that, I'm going to create second difference. So first difference is if I subtract 4a plus 2b plus c minus this, I get 3a plus b. Here if I do, I get 5a plus b. If I do here, 7a plus b. If I do this, I get 9a plus b. Next up is if you subtract this and this, that is going to give me the second difference, which is 2a. Here it is 2a, and here it is 2a. So that proves that it's a quadratic sequence since the difference is the same. Now, the technique here is that I'm teaching an alternate technique of finding the nth term formula. And what becomes really interesting is that the terms that you're going to use. So let's say when I'm using my first term is this, second term, third term. These things I'm going to use to find out the nth term formula for this quadratic sequence. So let's just take the same sequence that we took earlier for finding out the general term formula. So let's say the sequence that I took in the beginning is -3, 8, 23, 42, and 65. And what I do is I'm actually going to just create now the same thing that I did out here. So -3, 8, 23, 42, and 65. So now I'm going to create the difference, which is here 11. Here it is 23 minus 8, which is 15. And here, if I take 43 minus 20, this is 42 minus 23, it is 19. And this is 65 minus 42, so it's 23. So the second difference is 4. Here, second difference is 4. So what we get is the nth formula for this particular sequence now is I'm going to just use these numbers that are circled. So I'm just going to use these three numbers, the first number, the first difference, first number, and the second difference. So if you compare, this number is actually a plus b plus c, the first number. The second number is 11, and this is 4. And that's why you were dividing, earlier by 2. So 4 equals to 2a, actually. So I'll just tell you now the logic of that division. So 2a equals to 4. And so that's how I got a as 2. And you remember that when we did that, we got the second difference, and we divided that number by 2 in order to get the coefficient. So that was the trick out there to find out the particular value of a. So once you got the a value, now 11 is actually 3a plus b equals to 11. So 3a, 3 times 2, plus b equals to 11. So b is actually 5. And once you got b is 5, then to get the a, the first number, you're going to equate this with this, which is a plus b plus c equals to -3. And you already know a and b, which is 2 and 5, plus c equals to -3. So c is actually negative 5 plus 7, which is 5 plus 2 is 7, and -10. So that's the nth term that you get here is actually a is 2, so 2n square plus 5n and minus 10. Now let's take, if I take n as 1, am I getting the nth term correctly? So if I take n as 1, I get 2 plus 5 minus 10, which is -3. So that's absolutely right. And so you can verify for the other terms as well. So just to summarize, once you create the difference, you equate the second difference with 2a. This first difference, first number equate to 3a plus b. You got to remember these: a plus b plus c, 3a plus b, and 2a. Or you can instantly create this. It doesn't take much time. So 2a is actually, I'll just quickly erase the other stuff that I don't want here. So yeah, so now just to confirm, these terms that equate is 2a is the second difference, first number. This is 11, and this is for the first term. So you're going to use just these three terms to find out the nth term of the sequence. If you're not clear, you can rewind this video and watch it again. So I hope this is helpful, and just keep working on more problems to get more confident.